Okay, so what did you guys get for pi out of 4? What's the answer to that? 45 degrees. And this one is 60 degrees. And this one 52 degrees. How? Multiply by 180 and multiply by 180 divide by pi. The pi cancels out. 45, that's once. By 45, that's 4 times. 4 times 13 is 52. Okay. So you don't have to memorize all those angles, Zoe. You can't. Yeah. But there are 3 important angles. The 60-degree angle, which comes from this triangle. Remember this triangle? So that's the 60-degree angle, 60 degrees, and 60 degrees. And this triangle, the 45-degree. This is 2, that's 1 and 1. That's 45 degrees. So these 2 triangles can help you get the ratios for 30, 60, 45, and 90. Right? Now once you have the ratios for these angles, you have the sine. When I say ratios, I mean the sine, cosine, tan for each of these angles, right? You have those fractions, the halves, the root 3 over 2. Once you have them, then you go to this circle. The unit circle. Sorry? How do you find 30? 30 is, if I split this in half, right? This angle is 30 degrees. This side is 1. The height is root 3, Pythagoras. So the sine of 30 is 1 over 2, like that. Anyways, once you get those angles, you come to this circle. So you have the first angle here is, the smallest one is 30 degrees, right? The next one is, nope, 45. And the third one is 60 degrees. Now each of these angles has a corresponding coterminal angle in every quadrant, right? So what's the coterminal angle to 30 in this quadrant? Another angle. Starting from here, what's that coterminal angle? So basically, yeah, 150. So 150 will have the same ratios as 30, except for the signs. You need to remember to place the signs properly, because in this quadrant, all of them are positive. Here only sine is positive, here only tan, and here only cosine. What is the coterminal angle to 45? 1? Yeah, 135. 135 has the same ratios as 45. What's the one for 60? 120. Again, it has the same ratios as 60. Just remember to use the correct signs. In this quadrant, what's the coterminal angle to 30? 210. How are you getting that? Sorry? 180. Yeah, 180 plus 30. What's the coterminal angle to 60? No, sorry, to 45. Thank you. 225. How did you get that? Yep. Can someone else answer, please? What is the coterminal angle to 60? 240. How did you get it? Yeah. You added 60 to 180, right? 180, yeah. And just remember, the ratios are the same. The signs are different depending on which quadrant you're using, okay? In this quadrant, Mikhail, what's the coterminal angle to 30? 330. 330. What's the coterminal angle to 60, Micah? Sorry? So you just subtract 360 minus 30 gives you 330. I'm pretty sure it's the other one. 360 minus what? You got it wrong. Oh, wait. What did I get wrong?
Which one? Oh, so that's the 0. Okay.
Yeah. So this is the 0 and 360.
You have to do it from the x.
Yeah. The coterminal angle to 45, is 315. And the coterminal angle to 60 is 300 degrees. So please, you cannot remember what the ratios are for all of these, but if you know the ratios for these three especially, because 90 is obvious, if you know the ones for these three especially, or if you know how to get them from the triangles, right, then you can go ahead and get all these ones. Now, another thing you should practice or be comfortable with is knowing what these angles are in radians. So without even doing it, what is 30 in radians? Pi over 6. And 45 is 63. So I would encourage you to draw this circle on your own and then write the angles in radians, right? And if you want, go ahead and write the ratios for sine, cosine, and tan, if you want, just for your own practice, okay? Okay, moving on. These are some radians that are often used: 90, 45, 30, 60, and 270. Sorry? Are we going too fast? You guys shouldn't be copying this. You should be converting them. Convert them, don't copy. You don't even know what the questions are?
What is 70 there?
270. Why 270?
90, 45, 30, 60. Okay, moving on. If you see an angle listed with a pi in the measure, right, or a number with no degree symbol, that angle is in radians.
Wait, what's the line for it?
That's just saying it was in the line.
Sorry?
Oh,
Or a fraction.
Yeah, it's just. So if you see, usually some people write an answer like pi over 6 radians or 3 radians, right? But if you see an angle measure that's written and there is no degree symbol, just go ahead and assume that that is in radians, okay? And if it has a pi and it's a degree measure, that's already in radians. Let's talk about area of a sector. So the other day we talked about arc length, right? And this will always go back to the definition of a radian. Do you guys remember what a radian is?
yes.
What is a radian?
The ratio of the circumference to the
Yes. So now could you say that again, please?
ratio of the circumference to the radius.
Yes. So it's the ratio of the circumference or any portion of the circumference to the radius. Okay? Whatever angle I have here, it's going to be defined as the ratio of the portion of the circumference that it what's the word? Encloses? Yeah. The portion of the circumference that it subtends divided by the radius. Okay? That ratio is going to be consistent no matter what that angle is. So even if the angle is this one and that's S, then that angle is going to be equal to the ratio of that portion of the circumference divided by the radius. Now, I hope you can see that an angle here at the center also cuts out a sector of the circle, a portion of the circle or a sector of the circle. Now, since a radian is a fraction of the circumference to the radius, what do you think a sector, how would I be able to get the area of this sector, for example?
Radius times length.
This is a portion of the circle, right? And this portion of the circle is subtended by this angle here at the center, okay? So, since I already know that a radian is a portion of the circumference, if I want to find the area of this sector, it's also going to be a portion of the circle. It's going to be a certain fraction of the area of the circle. The area of the circle is pi r squared, and this fraction here of the circle is going to be determined by what angle I have at that position. Okay? So the area of a sector is simply a fraction of the area of the circle, and it's a fraction of the angle at the center of the circle. Now, Since it is theta divided by 360 degrees, that's if the angle is in degrees. What would that look like if the angle was in radians?
Instead of in radians over 2,
Sorry?
maybe over 2 pi then.
If I wanted to change, because right now this is in radians, right? I have the x is a degree in radians. Let me use theta. Sorry, currently theta is in degrees, and it's out of 360, right? But if I wanted to write this formula in terms of radians, where this angle is a radian, what would that look like?
Then the angle will be over 2 pi when we change it.
Sorry?
It will be over 2 pi. Right?
Yes, I want to change this angle here to radians. How do I change angles to radians? Yeah. Sorry? Multiply by 180?
No, by 2 pi and then
Multiply by pi over 180. So I am changing that angle to radians, but remember it was out of 360. Then times pi r squared. Right? Is this right?
Oh, because you wanted it in radians.
Yeah.
maybe when it be over 2 pi though.
Over?
Maybe over 2
Oh, sorry. I'm changing the 360 degrees to radians, right? And 360 is the same as 2 pi radians. Yeah, that's a simpler way. Then times pi r squared. So I end up having, what does this equation turn out to be?
0 pi r squared 2 pi.
Theta
Yeah,
r squared divided by 2, because the pi cancels. Yeah, so that's the formula for the area of a sector. It's simply a half r squared times theta if the angle is in radians, or it is this if the angle is in degrees. Going forward, we by the way did this in 9th grade. Yeah. Sorry?
half r squared.
Before I just wrote it like this, but it's the same thing. This one is confusing. It's the same thing. Half r squared theta, or half theta r squared. What is the length of this arc? Anyone? Remember the formula for arc length is S equals r theta. So the arc length, this one here, the red, is radius, which is 4.5, times the angle, which is 2 pi out of 5.
It will be 5.65.
Do we have to?
5.6 pi. Can you give it as a decimal?
And is it,
Oh, yeah, sure.
is it supposed to
It'd be
say
none of the
as
five pi.
radians?
No, as a decimal in centimeters.
Isn't that what I said?
Multiply the pi.
What?
5.6
Sorry?
times
What?
1.
Multiply out the pi so that you give me an answer that's in decimal.
I'm confused.
I got 5.6.
Do 5.6 times pi.
Why?
Why am I multiplying?
Because I want to get the answer as centimeters.
What?
Yes, Micah?
Why is there pi?
Yeah, why is
And because it's already in radians.
Yeah. This angle is in radians. And the angle in radians is 2 pi out of 5.
Yeah.
So I multiplied that angle by the radius.
And times 4.5.
What you divided?
You get 5.65.
Okay. Can everyone give me that answer as a decimal? 18 point? Oh, 17.76.
Why? That's not realistic.
That's high.
Sorry?
That's not really a realistic answer.
17.6.
The radius barely gets to 4.5.
Guys, I'm not getting why you're confused.
Why you start from the top?
Why multiply by 5?
If you don't have to. Yes?
Alright, so if you just take that equation straight, so
This one.
2 pi over 5, right?
Yeah.
1.2566.
Yeah.
Multiply that by 4.5, and then it's just 5.6.
Yeah.
So there's no pi.
Not 5. Because it's already in range.
Why did Mikael tell me there's a pi?
What do you mean? No, I didn't.
You said 5.6 pi.
No, I didn't.
Yeah, you did.
No.
Yeah, and
I said
you.
9 pi over 5, which if you like put it in decimals would be 5.65.
My goodness.
Oh, Mr. Lynn,
Yeah.
yesterday,
Hmm.
on example 5,
Mm-hmm.
or not yesterday, Monday, we found the length of the arc,
Yeah.
and we did 12 times pi over the whole,
Mhm.
and that when we put a pi, is it different place?
It's fine. Whichever way I changed it to centimeters here because the radius was given in centimeters. I mean, it was given as a decimal, so that's why I
The
wanted.
area is smaller than the light.
The area of a sector,
Yeah.
did you use half r squared theta,
Nope, I used the other one you gave us.
which is this one?
The 0.
Theta,
The
theta.
r squared over 2. Oh.
Same thing. So you have half times 4.5 squared times 2 pi out of 5. What does that give? 12.7. What's the units? Yeah. Sorry?
Wait, so the arc
These different
was
questions.
5.6 centimeters?
Yeah, the arc length was 5.6 centimeters. And
She just gave it a pi.
these guys multiplied it out. But if you didn't want to multiply out the pi, I think the answer was 9 pi out of 5, which is like 1 point something pi. 1.8 pi, is it? Yeah. So if you want to leave the pi, that's fine. Okay, let's talk a little bit about angular speed, and the physics people will be celebrating here.
Oh, it's angular.
How did you pronounce it?
We have angular.
Ooh.
It doesn't have the A.
Angular speed. So imagine a disk, right? Or a turntable, or just a disk, or anything that spins, right? If you have anything that spins, so I'm imagining a disk, it's spinning. As it is spinning, imagine something is located here, right? If you give it a certain force and it spins in that direction, this little thing here, maybe it's a peanut, it's going to end up in this position, correct? If you spin it that way. Yep. So this peanut has gone through a certain angle, right? And that motion of going through a certain angle has happened in a certain, has happened in a certain time, right? So angular speed is simply how fast that angle changed. Angular speed, we represent it with the letter omega. This is a Greek letter omega, and I'm not doing justice to it. I think it's written like some funny thing like that, but we just use W. Angular speed is simply how fast the angle changes, right? How fast the angle has changed is the angular speed. Because we know normal speed is distance divided by time, right? So therefore angular speed will have to be the change in the angle divided by the time. Simply angle divided by time. So that's angular speed. Linear speed, I've just talked about this. Linear speed is known as the distance divided by time. So how do angular and linear speed compare? If you think about it critically,
What was the equation for linear speed?
distance divided by time, S over T. Sorry?
You said distance over time, and they said S over T.
Yeah, S is standing for distance. Yeah. And T is standing for time.
Isn't that because of the arc length?
Yeah.
Yeah, it's like the.
That's because when we talked about arc length, we still used S as our distance. So you guys remember that S is the same thing as R times theta,
Yeah.
right? S is equal to R theta. So basically it's the same thing as R theta divided by T, since S is equal to R theta. So where does that lead us? If you look close enough, I have this quantity theta divided by time, right? Theta divided by time, and previously we had said that theta divided by time is what we call the angular speed. So in place of theta over t, I'm going to replace that with omega, because theta over t is omega. So I hope you can see the relationship that V is also equal to R times omega. Now, all of this should not confuse you. The takeaway that I want you to take from this is simply two things. One is that angular speed is equal to the angle divided by time. That angle is in radians. The second one is that linear speed is equal to the radius times the angular speed. These are the equations we are going to use. How they get there, no one is going to ask you. Okay? Linear speed is equal to radius times angular speed. Yes, linear speed is also equal to S over T. That is, distance is equal to speed times time. That is known by everyone, right? But this just helps us see how linear speed, or the relationship between linear speed and angular speed. Angular speed.
Only showing the relationship, that's not like how you find the V.
It is how you find V when you have omega. Yes. So the only two things you should concern yourself with are this equation, omega is equal to angle divided by time, and this equation that V is equal to radius times omega. Okay? This whole process of how it gets there, if it's confusing you, don't like get stuck there. These are the key ideas. So yeah, this is the equation I was talking about. The relationship between linear speed and angular speed is V is equal to R times omega. Okay, here's an example. We have a truck with a 32-inch diameter. Wheels are traveling at 60 miles per hour. So 60 miles per hour, that is the linear speed. Okay? 60 miles per hour. Find the angular speed of the wheels in radians per minute. How many revolutions per minute do the wheels make? So they've given us the linear speed and they want us to get the angular speed. Which equation relates those two quantities? Yeah. Yeah. Sorry? Can you ask that one more time? Yes. 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 So for this one, we would use this equation. V equals omega R, and then like Alwell said, 60 is equal to, we want omega times the radius, which is 32.
That's the diameter.
And then what? Oh, diameter, sorry. That's the diameter, so the radius is 16. So I divide both sides by 16, and then I end up with omega is equal to,
Where'd you get 16 from?
The 32 is the diameter.
Oh, so you were related.
yeah. So what's the omega?
We have to convert something.
Units?
Yeah.
No.
So that's miles.
We can always change
That's
that.
in inches.
This is math. Sorry? 3.75. What are the units?
Oh,
Yes, Micah?
I actually don't know. Sorry.
What are the units?
Oh, wait. Okay, no.
Rads per minute?
Is it?
No.
It says how many revolutions. Isn't that like going around?
Uh-huh.
Yeah.
So would it be pi? Because it's.
Rads per minute.
Please, it's coming at 60 miles an hour.
If it's traveling at 60 miles per hour, how can this be rads per minute? This would have to be rads per hour, right? So now we need to change this to rads per minute.
You divide it by 60?
How do you change it to per minute?
I still think we're good.
By multiply.
Seems right to me.
Do you want to change the miles to meters?
At first I also thought it was weird, but
You're going 60 miles an hour and you only have to cover 16 inches. That's like a foot. It's like this big of a wheel.
No.
60 miles an hour. That's not a lot of 2
The diameter is not the distance that it covers on the ground.
Yeah, it's the whole circle. The whole 2
The circumference is what it covers on the ground. Yeah.
Oh, so that's like 100.
So how do you change this to radians per minute, guys?
Multiply by 60.
Ready?
you divided it, but
Oh, yeah, we divided it.
3.75 radians divided by hour, and an hour is 60 minutes, right? Okay. Mikhail, take over. You guys complete that example.
what do you mean take over?
It's going to 20. Oh, no. You multiply.
Why would you multiply this?
Wouldn't it be 16?
Mikhail, they don't answer from
Wait.
100.5
Because we just.
inches. That's like 5.
Oh, I got it.
10 miles an hour.
I got it.
Think about it. 60 miles an hour.
Yeah.
Even if it is 5 feet, miles an hour. That's really fast.
So what's the answer in radians per minute? Are you multiplying by 60 or dividing by 60?
Why would you divide
I
it?
think it was dividing, but apparently it's multiplying.
Multiply. Oh, that's per
Guys, if you're doing 3.75 radians per hour, right, or revolutions per hour, are your revolutions per minute going to be more or less? Sorry,
96 kilometers an hour.
would they be more or less?
more minutes? More.
If you're doing, let's say you're doing 10 revolutions per hour, right? How many revolutions are you doing per minute? Are they going to be more or less? Per minute. If you do 10 in 1 hour, then in 1 minute, how many are you doing? So are we multiplying or dividing?
So it's in rads.
Sorry? Can you say that again?
Really small. Yeah, okay. So, in order to find the angulars, it would be like, how many rotations does it take? And it'd be easier to make it in 1 second.
Yeah.
But then,
What?
I did that. Yeah.
It'd be easier to make it in.
You can just multiply it by 60. 5 hours is really small time. Like,
Yeah. So how many revolutions per minute do the wheels make?
0.060.
0.0625. Now, I know the physics people are going to be complaining because in physics the very first thing you do is convert these units and these units to the same quantities. Okay? In a practical sense, that's what we're supposed to do. We're supposed to first change inches to miles, or miles to inches, such that we're working with uniform quantities. Okay? But mathematics has a way of ignoring physics rules. Yeah? Because if you change these inches to miles, this answer is going to make a lot more sense. Right? The point of the question is just to get you to practice how to use this formula, not to get hung up.
You get this answer in a test. Not supposed to
In a test, I'll try to make sure that the units are consistent, because I don't like them either.
What if they're not?
Sorry?
What if they're not?
Then I will instruct you to change them. Yeah. Okay, we are running out of time, but this is your homework. Now, hold up. What you're going to do is you're going to get started on this homework, right? Then I'm going to make, because I know some of you are still confused, I'm going to make a shorter video explaining especially this part, starting from angular velocity, right, all the way to the end, and then post it tonight as well. Okay?